Welcome to the third week of the Powering Agriculture Mooc on Sustainable Energy for Food. Within that initiative, USAID, the governments of Sweden and Germany, as well as Duke Energy and OPIC, promote clean energy solutions in the agriculture and food sector. For the Mooc, the partners are cooperating with TH Kim, a university of applied science based in Cologne, Germany.
Welcome everyone. My name is Miguel Franco and I'm going to be your lecturer for the day for the bioenergy session. We're going to be talking about three main topics on bioenergy. First, bioenergy resources and technologies. Second, what is biogas and why biogas in the agriculture sector? And finally, what are the biogas technologies and biogas uses in the agriculture value chain? So what is bioenergy? Bioenergy is widely known as the energy derived from biofuels, and biofuels are derived from biomass. You can summarize that bioenergy comes from biomass. Biomass is converted, either directly or indirectly, into an energy carrier, which will be the biofuel to use as the energy source. There are many types and sources of bioenergy. The types can be either liquid or solid, for example, and the sources can be agriculture sources or municipal solid waste sources or maybe forestry sources. Let's focus on agriculture sources given the focus of this session. So what are the main agriculture sources? They can be from farming, for example, livestock operations. They can be for energy crops. They can be from food waste and also from agro-industrial processes like palm oil mills or sugar refineries. They generate large amounts of high organic content waste that generates methane naturally because of the way they are disposed. So how do we transform this feedstock, these agriculture sources, into biofuels that we can use as an energy source? Well, there are several ways. It could be a direct way, like direct combustion, or it could be indirect ways like thermochemical transformations, like gasification or pyrolysis, or it could be biochemical transformations, like fermentation or anaerobic digestion. We will talk later about anaerobic digestion in more detail. In this next slide, you can see a summary of what I just said. You have the biomass on the left side, you have the transformational processes in the middle, and this could be gasification or fermentation or anaerobic digestion, and finally the type of biofuel that you generate through this transformational process. So now that we've seen the different technologies for bioenergy, let's focus more on anaerobic digestion. Why anaerobic digestion? Because it is commercially proven. It has been used in the agriculture sector for many years around the world. Many of these technologies are in place, are working right now, and their main product, their main result, which is biogas, is widely used in the industry. So what is biogas? Biogas is a mixture of methane, between 50–70%, carbon dioxide, around 30–40%, and some trace amounts of other components, like water vapor, for example. The feedstock will define the actual amounts of methane, carbon dioxide, and trace components. So how is methane formed? Well, methane can be formed both naturally and man-made, from man-made sources. Methane is formed in a three-step process. First, hydrolysis. Complex organic compounds are hydrolyzed and create alcohol and create organic acids. These are further reduced into acetate, hydrogen, and carbon dioxide, which then are further reduced by methane bacteria into methane and carbon dioxide. This process, like I mentioned, can be either naturally formed or it can be a product of man-made processes. Naturally formed, you can find it, for example, in wetlands, where the organic matter decay in the water and generate methane naturally. But the most important ones are actually the anthropogenic or man-made sources. For example, fossil fuel production and distribution. They generate large amounts of methane. Landfill wastes, livestock farming, rice cultivation, biomass burning. All these sources generate methane, and these are all man-made sources. The important part is that in the agriculture sector, particularly the farming, particularly the wastes from agro-industrial processes, these can be contained, the biogas can be captured, and it can be used as an energy carrier and replace fossil fuels. This has both climate change and economic benefits. So now that we know about biogas a bit more, let's talk about biogas technologies. In this first slide, you can see a schematic of a biogas system. The first component is the feedstock. It can be animal manure, it can be agro-industrial processed wastewaters. The second component is the anaerobic digestion system where the biogas is generated. And the final component are the biogas, which is the main product, and the effluent, which is a byproduct. And the effluent can be used for either irrigation or as fertilizer. The biogas is obviously used after cleaning up as an energy source, or it could be used for heating or lighting. So what are the main biogas technologies? The main biogas technologies can be roughly divided between large and small scale. Large scale are usually grid connected or captive user projects. These are complete mixed systems, cover anaerobic lagoons, upflow anaerobic sludge blankets, that type of technologies. The small scale technologies are floating drum, bag digesters, or maybe fixed dome digesters. These are more appropriate for household level users. So how do they use these technologies? And what is the appropriate technology? And how do you identify this technology? Well, as we mentioned, large scale and small scale immediately divide the type of project that you have. If you're going to be a grid connected, or if you're going to be selling large amounts of biogas and energy to an industry, a captive user, then you probably need a large scale technology. If you're just going to be using biogas for cooking at home, then most likely you need a small scale type of technology. So how do you compare these technologies? This next slide provides the advantages and disadvantages of each one, and this can help you select the appropriate technology based on the type of feedstock that you have. So now that we have the right technology, how do we use the biogas resulting from the anaerobic digestion process? Many ways to use the biogas. Cogeneration is probably the most significant one because it uses not only the biogas to generate electricity, but it also captures the heat when combusting the gas and recuperates the heat, increasing the efficiency of the overall system. There are also many other uses for biogas, for example, cooking and lighting, and vehicle fuel, although this one requires large amounts of biogas and also a lot of compression and costly capital costs. As a summary, what are the key lessons learned today? First, that bioenergy technologies and resources are diverse, that biogas technologies are commercially proven and that they work, and finally, that each project and each circumstance is different, and each technology will have to be tailored to the specific circumstance. Otherwise, it might not succeed. Thank you very much for attending today's course.
Thank you for your attention, and see you next week.